Example 2 is an example of Charles' law. So it's dealing with volumes and it's dealing with temperature. There's no mention of pressure or the mass or moles of a gas, so we assume that P and N are constant. So if we set up our equation, our initial volume, V1, is 6 liters. Our initial temperature, T1, is 25 degrees Celsius. The volume is increased, so our V2 is 10.3 liters. What is the temperature at this volume? So we're solving for T2, the final temperature. When we're solving for temperature, a way that we can save a little bit of time rearranging some time rearranging this is we can flip the equation so that our temperatures are in the numerator. So when we're solving for temperature, we can save a little bit of time rearranging if we flip it. So I'm trying to isolate T2. That means I need to move V2 over to the other side. So remember, when you're rearranging, you want to do the opposite operation. Right now, I'm dividing T2 by V2. Opposite of dividing is multiplying. So I want to multiply so I can cancel that over here. That means I need to multiply also on this side. So when it's all rearranged, I get T2 equals V2 times T1 divide by V1. Sub in my variables, so V2 is 10.3 liters. T1, I can't substitute degrees Celsius in here. I need to convert this to Kelvin, and we do that by adding 273. This will convert to Kelvin. When I add 273 to 25, I get 298 Kelvin. Initial volume is 6 liters. I end up getting a final temperature of 511.566 repeating Kelvin. So my temperature will end up in the units Kelvin because liters will cancel and we're left with Kelvin. If the question by chance asks you to put your answer in degrees Celsius, to convert from Kelvin back to degrees Celsius, we do the opposite. So we added 273 here. I would just subtract 273 if I wanted to get my answer in degrees Celsius. I'd end up with 238.5 degrees Celsius. If I wanted my final answer to be two significant digits, this would become 2.4 times 10 to the power of 2 degrees Celsius. I would move my decimal 2 spaces over. The 3 rounds up because this is an 8. So it would be 2.4 times 10 to the 2 degrees Celsius.